In this video, we'll be looking at how to identify what cations are present by doing different experiments. So starting with, first of all, cations are positively charged ions, one that would be attracted to the cathode in electrolysis. Examples would be Al3+, NH4-, NH4+, Ba2+, Ca2+, Cr3+, Mg2+, Mn2+, Zn2+. The two solutions that are used to test for cations would be sodium hydroxide and also ammonia solution, NH3. So we will now begin to see the test for cations. So first of all, to identify Al3+ cation, when you add a solution containing Al3+ with NaOH, an aqueous solution of sodium hydroxide, you will see white PPT, and when you add excess amount of the aqueous NaOH, it will be soluble. And when you add aqueous ammonia to the solution containing Al3+, it will be producing white PPT, and it will not dissolve in excess NH3. So let's look at the video here.
Aluminium ion is a colorless cation. Sodium hydroxide solution or aqueous ammonia solution can be used for the testing. Add sodium hydroxide solution to a solution containing aluminium ion.
White PPT is starting to form.
A white precipitate is formed. Add some aluminium hydroxide. If excess sodium hydroxide solution is added, the white precipitate will dissolve and a colorless solution will be obtained.
As you can see, the white PPT has dissolved in excess NaOH.
If aqueous ammonia solution is added to a solution containing aluminium ion, a white precipitate will be formed. Add is aluminium hydroxide. If excess aqueous ammonia solution is added, the white precipitate will not dissolve.
As you can see, the white PPT still remains, which differs from when you add excess aqueous NaOH. So meaning the white PPT will not dissolve in excess NH3. So moving on to the next cation would be Ca2+. To identify Ca2+ is present is when you add a solution of aqueous NaOH to the solution containing Ca2+, you will see white PPT present. And then when you add aqueous NH3 to it, you will see no PPT present. So the next slide will show the picture. This is when you add the solution containing the Ca2+ with NaOH, white PPT, and on the right side, you'll see no PPT present when added with aqueous ammonia. Moving on to the next one, barium Ba2+. So when you add aqueous NaOH solution to a solution containing Ba2+, you will see a faint white PPT unless the reagents are pure. And then when you add aqueous ammonia to the solution containing Ba2+, no PPT will be seen. So this is the picture as well. PPT with NaOH and no PPT with NH3. Moving on to the next one, copper to ion, Cu2+. When you add a solution containing Cu2+ with a solution of aqueous NaOH, you will see a blue PPT, and when you add an excess of sodium hydroxide, it will not dissolve. Although when you add NH3 with the solution containing Cu2+, initially a blue PPT will be formed, although the difference is the excess NH3 will make the blue PPT dissolve. So we'll look at the video here.
If sodium hydroxide solution is added to a solution containing carbon-2 ion, a blue gelatinous precipitate will be formed.
This is the blue PPT form.
It is carbon-2 hydroxide. Aqueous ammonia solution is added to a solution containing carbon-2 ion. A blue gelatinous precipitate will be formed. It is carbon-2 hydroxide. However, if excess aqueous ammonia solution is added, the precipitate will dissolve. Tetraamine carbon.
So this is the difference when you add excess NH3. The blue PPT earlier is dissolved into a dark blue tetramine copper 2 ion solution. So that's Cu2 plus.
If sodium
Moving on to the next cation is the iron 2 plus. So to indicate iron 2 plus, when you add an aqueous NaOH to the solution containing Fe2 plus, a green PPT will be formed and will turn brown with contact in air. And the green PPT will not dissolve in excess NaOH. Although for when adding with aqueous ammonia, the green PPT will also be formed, and also a similar result will be formed. Turns brown on contact with air, and the green PPT will not dissolve in excess ammonia. So if you look at the video,
iron 2 ion is a pale green ion. If sodium hydroxide solution is added to a solution containing iron 2 ion, a green gelatinous precipitate will be formed. It is iron 2 hydroxide.
so this is the green PPT form,
If excess alkaline solution is added, the precipitate will not.
and the person just added excess amount of NaOH, and it does not dissolve. And if the person does this experiment the same way using aqueous ammonia, the results will be the same. Green PPT will form and will not dissolve with excess ammonia. So moving on to the next cation will be the iron 3 plus. So to indicate between iron Fe2 plus and Fe3 plus is the colored PPT. So when you add the solution containing Fe3 plus with aqueous sodium hydroxide, a red-brown PPT will be formed and it will not dissolve with the excess NaOH. And similar result will be seen when added with aqueous ammonia. Red-brown PPT will be formed and will not dissolve when added with excess ammonia. As seen in the video.
Iron 3 ion is a pale yellow ion. If sodium hydroxide solution is added to a solution containing iron 3 ion, a brownish red gelatinous precipitate will be formed. It is iron 3 hydroxide.
Okay, so this is the red-brown PPT form.
If excess alkaline solution is added, the precipitate will not dissolve.
As you can see, the PPT does not dissolve when the person has added excess of the NaOH, and the result will be similar when the person does this experiment with ammonia. So moving on to the next cation, Mg2 plus. To identify Mg2 plus is when you add a solution which contains Mg2 plus with sodium hydroxide, a white PPT will be formed and will not dissolve in excess NaOH. And the same result will happen when you use ammonia. When you add ammonia, initially white PPT will be formed and will not dissolve in excess ammonia. So this is the video showing the person adding NaOH.
Containing magnesium cations.
The person added NaOH to the solution containing Mg2 plus. So white PPT is forming, as you can see, and when the person has added excess, which is right now, the person is adding the NaOH in excess, the PPT still remains here. So the excess sodium hydroxide does not dissolve, does not make the white PPT dissolve. So moving on with zinc, where Zn2+. To identify zinc 2+, white PPT will be formed when you add NaOH to a solution which contains Zn2+, and the white PPT will dissolve in excess NaOH. Same goes with ammonia. White PPT will be formed when added with ammonia, and the white PPT will dissolve in the excess ammonia. Seen the video, let's look at the video.
If sodium hydroxide solution is added to a solution containing zinc ion, a white gelatinous precipitate will be formed. It is zinc hydroxide. If excess sodium hydroxide solution is added, the white precipitate will dissolve. Colorless and water-soluble zincate ion is formed.
As you can see, the colorless solution, this is due to when the person added excess NaOH to the white PPT. So the same thing will occur here when the person is using ammonia. The white PPT dissolves and it will form a colorless solution.
And water-soluble tetraamine zinc ion is formed.
Here's a clearer picture of the colorless solution form. Okay, moving on to the next cation, NH4+. When you add aqueous NaOH to a solution containing NH4+, no PPT will be formed. But when heated, ammonia will be present. Ammonia gas will be released, which changes red litmus paper into blue.
If a strong base, such as sodium hydroxide solution, is added to a solution containing ammonium ion, and the mixture is heated, a colorless gas will be produced. The gas is ammonia. It turns moist red litmus paper into blue color.
Moving on to the next cation, manganese 2 ion. So when a solution containing Mn2+ is added with NaOH, aqueous NaOH, off-white PPT will be formed, and which will turn quickly turns brown when contact with air, and it will not dissolve in excess NaOH. And the same thing happens when you use ammonia. Off-white PPT will be produced and it rapidly turns brown on contact with air and will not dissolve in aqueous ammonia. Let's see the video.
Now add 1 ml of sodium hydroxide solution with the help of pipette. Observe here, the white precipitate gradually turns into brown color.
The white PPT quickly turns brown. That's why it was called off-white.
It indicates that the salt contains manganese ions.
So yeah, the same reaction will occur when you use NH3. So moving on to the last cation, chromium ion Cr3+. A gray-green PPT will be formed when you add NaOH, and it will be soluble in excess NaOH. And for ammonia, there will be a difference because the gray-green PPT form will not dissolve in excess ammonia. This is the video that Azri found. I'm not sure very much what this is. This is probably the gray-green PPT. Let me help with that. So in this video, the person is adding NaOH to the middle one, the middle test tube, and excess ammonia to the right test tube. So this one, the one with the NaOH, will not dissolve. My bad. The one with the NaOH will dissolve, and the one with the NH3 will not dissolve.
And continue on the right-hand test tube to add an excess of sodium hydroxide, and the precipitate will be dissolved. You can see that
so on the right side, the PPT is dissolved.
The water molecules is replaced by an OH minus ligand. The charge is re-established as 1 minus. So, in the first step, precipitation reaction produces a grey-green precipitate, and in the second step, with excess, precipitation reaction produces
So from this picture, basically the person has added excess NaOH to this one, the very end on the right test tube, so that's why the green PPT kind of dissolves. But for the middle one, the person did not add excess NaOH, so it did not dissolve. So that's for chromium ion.